Okay, so here we are in number 10, and they're saying classify each of the following as true or false. The bases of all cones are circles. No, they don't have to be circles. Let's go back and look. So back to cones. Here's cones. So and even look at the base here. See how that base right there? That's not a circle. It's a circular region, but it's not necessarily like a perfect circle. Even that doesn't really look like a perfect circle. It doesn't have to be a perfect circle. It just has to be a circular region to be the bottom of a cone or a cylinder. So we'll say false. The base can be any simple closed curve. Okay, next question. A cylinder has only one base. Is that true? A cylinder has only one base? Let's go back. No, cylinders have two bases, right? Top and bottom, kind of like a prism. It's like a prism with the top and the bottom being circular, right? A cylinder. Cone only has one base. It's like a pyramid, except the bottom is circular. That's what a cone is. A cone has one base, like a pyramid, and a cylinder has two bases, like a prism. So we come back here, and we say false. A cylinder has two bases. Next, all lateral faces, that means side faces, of an oblique prism are rectangular regions. An oblique prism. Well, if you go back, we actually have an oblique prism back here, there. So notice this one right here. Notice these two prisms, right? Here's an oblique hexagonal prism, and here's a right hexagonal prism. And they're talking about the sides. Well, look at the side here. What kind of shape is that compared to this? You see, an oblique shape is one that's leaning, and a right shape is straight up and down. So this is a rectangle because it's straight up and down, whereas the other one, it's hard to tell, but it's more like this. Let me make it more extreme and you'll be able to see. You see the sides for an oblique shape, for an oblique prism, the sides are parallelograms. You see, that's a parallelogram. It's not a rectangle. The angles are not 90 degrees, right? It's a parallelogram, the sides, for an oblique prism, because an oblique shape is leaning, and a right shape is like this. A right shape, it's straight up and down, and the sides are rectangles. So, false. The lateral faces, the side faces, are parallelograms that are not rectangles. That's what they are. All right, question D. All regular polyhedra are convex. So convex means, so they're not caved in, right? Concave is the opposite of convex. Concave is the opposite of convex. Remember, concave means caved in. So polyhedra, they are all convex. So that's going to be a true statement, because there's no way a three-dimensional polyhedron can cave in. All the sides are straight. They're made out of polygons, so there's no way it can cave in. A cube has congruent edges. Yeah, cube, that's like a die, six-sided die. Yeah, all congruent just means equal, right? Yeah, all the edges are equal. Yeah, that's true. Everything's equal. It's a perfect shape. F, any pair of opposite faces of a rectangular prism can be bases. A rectangular prism. What's a rectangular prism? Remember a prism, so we would have a rectangle here. Let me make it, that looks like a perfect square. So let me make it more like this. So a rectangle here, and a rectangle here. That's the top and the bottom. And these would be the sides. So that's a rectangular prism, right? Because it's got a rectangle on the top and a rectangle on the bottom. The purple top and the purple bottom are rectangles, so it's a rectangular prism. But notice you could switch that. You could say this is now the top and this is the bottom, and it's still a rectangular prism, isn't it? So yeah, any pair of opposite sides can be the bases. It's true. Kind of interesting. All right, number 11. So basically they're asking us to take this and rotate it about that line. We're going to rotate it, and imagine rotating it super fast, and what kind of a three-dimensional shape will it produce? Well, this will go out like this will go out like this, and it'll sweep this in a circle, and it'll sweep this down here in a circle. So what will it end up looking like? It'll end up looking like that, won't it? An hourglass kind of shape, like that. So how about question B down here? Same kind of thing. We're going to spin this like this, spin it around. What kind of three-dimensional shape will it make? Well, something like that, three-dimensional, where this comes rounded. So yeah, it's going to be A on that, isn't it? Three-dimensional as it spins around. This is all about picturing things in the third dimension. So part C, we're going to take this one and spin it around. So it's going to spin around like this, be rounded like that. What's going to make a? It's going to make a cone. It's going to be rounded down here and come up to a point on the top. And then D here, this shape. So if you spin this around, this will go over like this, and the top and the bottom will be rounded. It's gonna be round on the top and round on the bottom with that kind of shape. So it's going to be D. As we spin it around, it'll look like that in 3 dimensions. Now, number 12 is also about picturing things in 3 dimensions, and it's really pretty tricky. Let me show you. Let me help with this one. So they're basically saying, okay, you got this net, which is a flat version that you're going to cut out and fold into a 3-dimensional shape, and which of these 4 will it end up being? This is pretty tricky. You really have to kind of picture things. Basically, the best help I can offer you, it's going to be this one, and the reason is, can you see that this 5 and 2, see how they're connected? And this 1 and 5 will end up connecting. When you fold down the 5 and connect with the 1, it'll be right there on the right side, like that. So that's actually right. That's correct. You might think, well, there's the 5 and the 2 right there. Yeah, but that's not going to be right. First off, the 6 is not going to be there. It's going to be down. When that 6 folds up this way, it's going to be underneath the 5, down here in the bottom, not beside it. And the 2 is oriented wrong. The 5 and the 2 are both straight up. See how the 5 and the 2 are both straight up? So there it is on C. How about down here, part B, choose the correct. So we're going to take, now we're going to take this and cut it out and fold it into 3 dimensions. Which one is this one? Well, this 2 is pretty tricky. It's going to actually be B here, and the way you can tell that is specifically how these 2 are going to connect with each other. Do you see this one right here? Let me use some colors to try to make this clear. This piece right here will come down and be this piece right here, and this piece right here will end up being this piece right here, and this blank side here will end up right there. Do you see that, how they're going to connect? These 2 will connect, and this one will, they'll line up like that. Can you picture that? So it's that in the 3rd dimension. The other ones are not correct. You see, because this guy is going to fold down, and it'll look just like that. All right. Finally, number 13, Bonnie said the figure to the right is a rectangular prism because it has a rectangle as the base. How do you respond? Is that true? Is that thing a rectangular prism? Is that a true statement? Because you know, Bonnie knows that prisms, you name them by their bases. And so the base on the ground there, that's a rectangle, right? This is a rectangle down there on the ground. So that's a rectangular prism. No. No, prisms have two bases. You see, the trick is you've got to find what there's two of. What are there two of? There's not two rectangles, are there? What are there two of? There's two triangles. See these two triangles? Those are the bases. Those are the bases. This is a triangular prism. What Bonnie's forgetting is that prisms have two bases that match. And so it doesn't matter what's currently sitting on the ground. You can turn the prism upside down and turn it all around. It's still a triangular prism because what there's two of is there's two triangles. You got to look at what there's two of. There's two triangles. There's three rectangles, right? Three rectangles around the sides. Those are not the bases. It's always what there's two of. There's two triangles. So Bonnie is assuming that the rectangle is the base. However, the bases of a prism must be two congruent parallel faces. That's true. What's wrong with this one? Bonnie is assuming that since the rectangle is a base, that this is a rectangular prism. However, this is a rectangular pyramid? No, it's not a pyramid. All right. There we go.